People, how's it going? So today, we got yet another board to fix. Let's get started with this A1708 MacBook that appears to have liquid damage and not be powering on. Let's open it up and see if we can make it work again. Alright, so I get myself some... Where are magnets? Oh. Aha. Magnets. Now today is going to be the first day that I'm going to be using that little polarizer that you all recommend that I get. So this is a Heliopan SHPMC. That's Heliopan SHPMC. Pretty. So hopefully the microscope camera is going to be of better quality now. Now before I couldn't have used that because the microscope light wasn't strong enough. But since we've overclocked our microscope light to be able to put up to 30 volts into that thing, we should be able to have some fun. So let's open up the bottom of this machine. We started putting labels on the bottom of the machine as well as the top, so I can't show you a picture of the overhead camera of me taking the bottom cover off anymore, or else I will dox the customer an L style. You can hear behind me is an assistant, an angry Coopin-chan. Okay, now I'm pretty sure this one's going to be a complete and utter waste of time, and I'll show you why. So there's a lot of corrosion on all the wrong places. Here, the corrosion, as you can see, is on this screen connector area. And the reason this is very... Oh my god. You really do need some Dramamine for my screen, my overhead camera mount. I really do have to make some time to make that better. That's disgusting. Shake, 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 shake. Anyway, so let me just unplug the battery before I do this. Granted, this probably doesn't even matter at this point. This CPU is already roasted. But... okay, no power going to the machine. Okay, so let me show you why I'm not even going to open this thing at the moment. Ready? At least we'll get a nice test of the good old microscope light. Microscope camera view. Light on the camera. Alright. You see this over here? See that burn mark on the screen? By the way, let me know what you think of this polarizer filter. Is it make it better? I want to be able to highlight for high visibility while simultaneously being able to make everything out when I zoom in. And I wasn't able to do that before. So hopefully I'm getting my $120 worth here. Audio static, by the way. Okay, let's see. Does anybody else have static? I'd have to listen to my... Anyway, as you can see here... Thank you, Marcelo. I'm going to just raise the lighting a little more. Now we're at 13 volts going into the light. Light's probably not happy with that shit, but oh well. Sounds like phone GSM interference. Motherfucker. It happens with all these little Sennheiser wireless things eventually. I don't know why. I change frequency and it does the same thing. Maybe I should choose another band. You know what? Maybe I'll do a scan and I'll choose another band. How about it? Advanced. Pilot tone. Yeah.
What would you rather have? Chutney, green mango, pico de gallo, or yogurt sauce?
With any luck, that will be the end of it. If so, I just did a rescan of frequency. I figured I moved to a new place. Maybe someone else is using my frequency, or maybe there's interference on that frequency. So I'm using a new frequency. I did the little scan thing with the wireless, and if that doesn't work, then that just means this wireless thing's a piece of shit. So hopefully that fixes it. I'll give a listen to, because one of the problems is that I've had when I was streaming in the past is that people will say there's an issue and there's no issue, just a troll. And then other people will jump on the bandwagon because that's just the way of the world. So I should listen and also actually confirm that the problem I'm speaking about exists. So let's see, what does this sound like? Hello. Test. 1, 2, 3, 4, 5. Well, let's see, what does this sound like? Hello. Test. 1, 2, 3. Yeah, that's fine. I don't know what. Alright, so that works. Okay. Now that that is set and done, let me show you why it is this board will be a total waste of time. So, if we go to the microscope camera over here, you see all that burning? And see over here what happened with the cable? So, let me show you why that burns. And I want to really just kind of draw in the genius design of Apple engineering. Now, to be clear, I'm not saying that every single device you should be able to spill a cup of water on and have no maleffects. I'm not saying that I expect everything to be designed this way. But what I will say is that the failure that occurred here could occur very differently if this were designed by people who were using their brain. So why do you have that type of violent corrosion, and what is it that makes it something that is not commercially viable to fix for most people? Well, let's take a look at the display connector itself. So if we take a look at J8500 on the schematic, that is going to be the screen connector. And one thing you'll see is that we have pin 43 is LCD backlight, which is going to be somewhere between 39 to 50 volts. And then if you look at the pin that's going to be right across from it, that's going to be a pin for data. So if you're just purely reading the schematic, it seems like it's really far away, right? But if you switch over to the schematic view, the board view, watch what you find. So pin 43 is going to be up here. And pin 1 is embedded display port aux-N. And that is going to go straight to the CPU. So looking over here, it looks like 1 and 43, that's going to be far apart, right? But when it was routed over here, you didn't have anybody with a brain to say, maybe this line over here that is a 50 volt backlight line should not be right next to a 1.7 volt data line that goes straight to the CPU. But you don't understand. This was engineered by Apple Inc. So, of course 50 volts is going to go to the CPU. These people are crazier at overclocking than Linus is. Honestly, Linus could learn something from this, because I've watched his videos. I have never seen Linus send 50 volts to the CPU. That man does not have even half the balls that Tim Cook has. When's Linus going to send 50 volts to the CPU? No, but seriously, this is a complete and utter waste of my time, because that CPU is going to be dead. And where can I get that CPU? So let's say I want to buy this CPU, right? Let's take a look here. So, this is one of the things. Even if you have the machinery to do it, like, where are you going to buy that CPU? Well, that is an excellent, excellent question. So let's take a look through the schematic at a U0500, right? All right. So it said, look at the part number description. CPU SkyU QJ58. QJ58. All right, so QJ58. So let's just say we Google Intel QJ58, right? All right, let's go to my Googling. Google foo. QJ58 Intel CPU. Ah, go away. Okay, we get Intel. Missing QJ58. Missing QJ58. Missing QJ58. Missing QJ58. Like, where do you... What the... Like, what the... Blah. Yeah. No need to destroy the whole computer to get data safely removed. Just short the backlight voltage to the data pin and your data's gone. So how would you guys try to buy this thing? Like, what model CPU is even in here? Yeah, maybe one of these. 337 SOO 150. 337 SOO 150. You can't copy and paste out of Paul Daniels software. You can't even... Hello? 337 SOO 150. Three 337 SOO 153. Look up computer, find CPU. Like, what CPU comes in this MacBook though? It's so I'm looking for Sky. Is Sky Skylake? Like Skylake 2. I'm just messing with you, Paul. Thanks for being here. You put SSO, not SOO. Oh, yeah, good catch. All right, we got much better now. Ha! A link to the schematic. That's all you get. No, but seriously, what would you do? What would you do? I don't know. Everybody makes fun of my ability to source parts. What would you guys do? Cuke. A1708 2016. Rob Patterson. So what CPUs did they use that year? Let's see. A1708 2016 MacBook Pro. Everymac.com. This is what, okay, sixth generation Skylake 2 gigahertz i5. 6360U. All right, 6360U CPU. All right, I want to buy this CPU, but I get benchmark. I get, nah, that's not a, these are all benchmarks. All right, let's see. So you have boards that use it. I can't tell if I'm being trolled by Jim or not. The thing is, there are people that I've Skyped that have said, yeah, I can get this for you, but when I buy it, they show up bent. That's one of the main problems here. Like this, like AliExpress. They claim it. Oh my God. Okay, yeah, this right here. Fuck this. It's 225. That's the end of the line, folks. Yeah, so I think I bought from one of these places on AliExpress before, back when they were 150. Dude, okay, SR2JM. Now I'm kind of curious. SR2JM, do they have that listed in the PDF that way? Because maybe I could learn something about how to find them. Here we go. Okay, so these CPUs, I found, like, you can find it by this SR2JM. All right, so this stuff I couldn't find. So let's see if I could find it in the browser. SR2JM. Let's search by this, because most of the Intel codes are usually 5 digits. That's what I'm used to it being. Here we go. Intel CPU. So they didn't have some of them, but they have the rest of them. Maybe we could find something a little bit more legit looking. Mouser, stock, not available. Color me surprised. $325. $8,888. $378. Condition refurbished. Oh, like what? It was crashing. You noticed that 2 of the transistors were bad, so you just opened it up and cut those 2 out and replaced them? What is a refurbished CPU? Someone explain to me what a refurbished CPU is. Okay, that's a stencil template. Ugh, like there's really not much of an option other than just going to eBay and praying. I don't want to go to eBay and pray. All right, maybe I'm getting a CPU that's too high end. Let's downgrade them by 200 megahertz. SR2JC. Yeah, knew my balls. SR2JC. If we're willing to downgrade a little bit, can we get something? Yeah, well, let's arrange it by price so we avoid the stencils. You can actually... Wow, look at that. 100% test. Very good product. Oh, how did you test that BGA CPU? Okay. $127. But, like, how do I know that's actually good? Yeah. Meh. Refurb CPU. 100% test. So my problem here when it comes to doing BGA rework is A, what if there's an issue on the board besides the CPU? B, it takes an hour to get the thing off and on there. C, you're adding $127 to the process, but most of all, D, how do I know that that actually works? Intel is not selling the CPU to Shenzhen Kelly Electronic Co. Limited. They're taking that CPU off of another board that they don't know if that board works or not. They just take the CPU off and put it on there. And the way that these businesses tend to run is as follows. They will give a 100% refund to everybody that complains what they got doesn't work. And the people that don't ask for a refund, that's that. They get these boards in this condition. They rip the stuff off. They sell it. It doesn't matter to them if it works or not. How are you 100% testing this? Are you telling me that to sell this thing, you're actually soldering it to a board and then making sure it works? Because I know you don't have a socket jig set up for this. If you did, you'd be showing that you have it and saying, we test better than everybody else. You'd include that in your marketing. That audio does sound like RFI. Yeah, there's nothing I could do. Sorry, man. I changed frequency already. If that doesn't do it, then that's that. Well, let's see. Are you guys be... Let's see if there's a... They dead bug all chips. Oh, yeah, of course. 100% tested by buyer. Test 1. Test 1, 2, 3. Test. 1. Okay, that's barely noticeable. Test 1. I wonder if that's my bike charging. 2, 3. Is that my bike charging? Okay, that's barely noticeable. Test 1. I wonder if that's my bike charging. 2, 3. Is that my bike charging? Okay, that's barely noticeable. Oh, my bike wasn't even charging. Is that my batteries needing to recharge? Maybe it's the batteries needing to recharge. I just squelched because you just killed everybody with noise. Oh, it's set. Check it out. I'll show you. Everybody doesn't believe me with this thing. Watch this. Even with squelch set to high, I'm gonna turn off the transmitter, and you're still gonna hear static. Watch this. All right. 5. Everybody, get ready to take your headphones off or lower your volume. 5, 4, 3, 2, 1. Huh. Interesting. It worked. I used to have squelch set to medium, and it would work. But no, I used to have it set to low, and it didn't work. Then I set it to medium, and it worked, and then it stopped. Now I have to have it at high? I don't know. That seems kind of crazy. Let me try it back to middle. What happens? All right. 5. On the count. Once I count down to 1, turn your headphones off. 5, 4, 3, 2, 1, 0. Five, four, three, two, 1, 0. Headphones off. So lame. What if I just turn up the sensitivity here? And conversely, turn down the output here. Test. Let's see. What does this do? 5, 4, 3, 2, 1, 0. Take off your headphones now. Doesn't make a damn bit of sense. That does not make a damn bit of sense. That's really strange. Roadlink uses 2.4 gigahertz with frequency hopping. Yeah, I should probably get something else. And you're all complaining he warned you. Yeah, but you're assuming people are listening, Alex. What are you, fucking crazy? I don't get why you have to have squelch set on high on this thing. Like, it used to work at low. Then it worked at medium. Now it only works at high? Like, that's just nuts. There's no good reason for that. I don't know. I'm kind of disappointed in the Sennheiser shit because it's expensive. All right. Anyway, so yeah, I'm not spending $115 in a CPU that is half chance not even gonna work. Fuck that. Once the Zamo is set up, like Chris really wants to try this just for the hell of it, but not it. 304. BRB. You know what? I'll put squelch back on high because I know that this is gonna deafen you all if I don't. Squelch is now on high. Let's see if that works. If it doesn't, I cave. Linux Guru Gamer, what's your name? And I will look you up. I am working on a large backlog of tickets. If you put your name or your ticket number in chat, I will try and find you. Thank you, Linux Dog. Oh, shit. I'm not logged into Twitch. I'm using a multi-chat thing. When I log into Twitch, it asks for two-factor authentication, which is a pain in the ass, so I wind up never logging into Twitch. Let's see. Will it ask for two-factor authentication here? Okay, I found it. Thank God it didn't ask for two-factor. Twitch requiring two-factor authentication is one of the main reasons I never log into Twitch. The last thing I want to do is grab my phone and log in when I'm ready to stream. Hell no. Alright, I found you. Bada bing. Let's see where this is. Alright. Okay, that's a battery replacement, so that's going to be done by the other dude here. I don't do battery replacements. I suck. They blow up in my face. And the other one is an air does not power on, estimate needed. Okay. Okay, now here's the thing. You're going to learn a dirty little secret here. Don't tell anybody. Don't. I don't give people estimates before fixing their shit. It winds up being a waste of my time. What I do, 90% of the time, if I think that the problem with the machine is something that is somewhat reasonable, I fix it, then I know what's wrong with it, then I give them the estimate. There, you fucking broke me. We'll see if this winds up kicking me in the dick later. Like 90% of the time 95% of the time people say yes, and the 5% that they don't, they just wind up getting a fixed computer. Or a half fix, because sometimes I won't finish it. But let's see. So now you know my fucking secret. Better not take advantage of this. All right. Let's see. Let me get your machine. If they decline, I put a wire to short PP3. That's just kind of being a douche. I've actually taken time to undo repairs before under very, very fucking limited circumstances, and it's usually when someone has gone above and out of their way to be as much of a douchebag as possible. But that's really, really, really rare. 99% of the time, it's like, okay, you decline, you get it back, whatever. Sometimes it comes back to bite me in the ass. So this has actually come back to bite me in the ass a couple of times, because there was this one guy that needed a board repair plus a keyboard. His keyboard didn't work, right? And so we fixed the board. I fixed the board on stream. The guy declined the repair because, that's totally fine. You're welcome to decline estimates. I don't mind. And then we send it back to him. And he says, you fucks. You said this needed a board and a keyboard. All it needed is a keyboard. You were trying to rip me off. So now the people here are saying if somebody declines, you need to undo the work that you did. In my head, I'm thinking, I already did the fucking job. I did it for a YouTube video. Why am I going to undo it and be a dick? But the way Steve and Paul explain it, if I fix the board and then it needs other stuff and they get it back, then they're going to think that our estimate was a lie. And then when we say, oh, no, we fixed this stuff before we sent it back, the same thing always happens. Yeah, right. Sure you did. I don't know. I don't have it in me to do that stuff. That's one of the growing pains with having a business. At some point, you get to a point where you're big enough that you have to start treating people like douchebags, but I don't want to do that. I don't know. I hate that shit. I'd be happy. Anyway. Hell, just today, I had someone email me that I've offered money to 3 times who said, I don't think you appreciate what I'm doing for you. And it's like somebody who's been helping with something, and I don't want to give away details because I don't want to seem like a douchebag too early, because it's hard for me to tell when I'm overreacting and underreacting. But there's this person that was helping me with something, and I thought, wow, you did really amazing work. I'd like to... Squelch tone is 19 kilohertz in G3, so maybe something activates the receivers. LED ceiling panels, huh? If not, scan RF with RTLSD. What? Rittelster? Rittelster. Yes, I will. Yes, let me just take my Rittelster out of my pocket. Anyway, this is one person that helped me really a lot. And I said, okay, how can I pay you? He ignored me. I said, please, how can I pay you? Let me know how I can pay you. He ignored me. And then I get an email today saying, it doesn't seem like you appreciate anything I've done for you. And it's like, that's what you get for putting your email out there publicly when you have 1 million subscribers. Anyway, I'm going to stop ranting and rambling and bitching. Let's fix this computer. All right. You all ready? Are you all ready for another episode of Broken MacBook Repair? So today we're looking at an A1466 that doesn't power on. Hey everybody, how's it going? So today it's time for yet another episode of Broken MacBook Board Repair. Let's take a look at this MacBook, which is an A1466 MacBook Air. See if we can figure out what's wrong with it and make this board work again. First thing that we're going to do is unplug the battery. We're going to turn on our power supply and see how many amps this MacBook takes, because that's going to tell us what's wrong with it. All right, get the power supply software on the screen. Get that beautiful Paul Daniels multimeter software on the screen. And turn this thing on. 12 to 24 milliamps, which means this is probably missing PM Sleep S4L, the most annoying board repair there is. Yay. Is PP bus present? PP bus is 4.2 volts on that side and 4.2 volts here. So it looks like we're actually missing our PP bus. This is not going to be PM Sleep S4L missing. This is going to be PP bus missing. I've never experienced that on an Air at 24 milliamps. That's very strange. So let's get the board out of the case and see if we can figure out what's going on. I'm going to guess that this machine has liquid damage on the ISL 6259 chip. The PP bus. And Carl, that's total junk. All right. And as you can see, we have corrosion in just the area that I anticipated, the ISL 6259 area. So now what I'd like to do is see if that polarizer filter that I got for my microscope camera makes a difference. A lot of you have been suggesting that I get a polarizer filter so that when I solder and there's flux, the reflections are a little less annoying, and also when I turn up the lights so you can see the detail, you don't see all the annoying reflections off the components. This thing was about $120 after tax at Adorama. To be honest, I kind of just wanted an excuse to go to Adorama so that I could take a look at the Sony FX7 and FX9, which I did for about half an hour. I was able to leave Adorama without purchasing a new camera. That is way outside of my budget. But I just wanted an excuse to kind of go and play with look at my toy. So let's see what this looks like under the microscope, and let's see if we can get this thing to work again. So I'm going to turn on the microscope light. Now the thing is, in the past, a polarizer filter wouldn't have really worked because you need to have a lot of light, because it kind of turns down your light. However, I have since overclocked my light. I have overclocked my light so that, yeah, look at that. Alright, so hopefully the detail will be better now. Let me just lock the microscope in place so that it doesn't shake as much. There we go. Is that a nice quality image? Hopefully that looks better than it did before. Thank you everybody for your suggestions here for the polarizer filter. I really appreciate it. If the video looks better now than it used to, well, every one of you who suggested that I get this polarizer filter, give yourself a little pat in the back, because this superior video is because of you. I really do like excuses to spend money at Adorama and B&H. It's an addiction. Now these, I imagine, are the current sense resistors, and they look toasted. This is the 48mm one, Criminal Minded. The whole concept is that when I use flux and solder and all that, there's or alcohol or anything, there's usually a lot of reflections, and there's also, when I turn the light up, reflections off of the metal from the solder pads themselves. And that with the polarizing filter, you should see less of that. That's the idea. And let's see if that's how it works out in practice. So let's add some flux here. See if I can kind of scrape away and get those points back to their beautiful luster. Now the pads for the resistor themselves seem fine. It's the pathway between the resistor and the chip that seems broken. So you see this? You see how there's like this over here? Yeah, I'm gonna up. Also, I can up the light. It's bright. Nope. Light doesn't like more than 14 volts. All right. There we go. I upped the exposure to a Vice TV level. Vice TV contract level of exposure there. Yeah, I gotta turn the light down a little. It's starting to flicker. It doesn't like getting 14 volts. There we go. Alright, so you can still have all the flux there, but still get a good picture when the light is high. Awesome. So here you can see that the probe point is kind of broken. Now, I'm not trying to solder on top of it. What I'm trying to do is scrape away the corrosion. Scrape away the corrosion. And then solder over. Same thing here. Just mild scraping at first. And there I can't. So here I may be able to get away without a jumper. Probably not. Here I definitely need a jumper. So we're going to install a couple of jumpers over here. Now our main issue appears to be that one of the current sense resistors is not connecting to the ISL6259. So there is a current sense resistor on the other side of the board, and the way this works is the current sense resistor is going to have a really small drop in voltage across it. And that small drop in voltage across the current sense resistor is going to let our ISL6259 know how much current the system is using. The larger the voltage drop across the resistor, the more current the system is using. The less voltage drop across the resistor, the less current that the system is using. Now, on each end of the current sense resistor, on the beginning and the end of it, there is yet another resistor, and its purpose is to go to the ISL6259 from the current sense resistor, so that the ISL6259 can see what's happening on each side of the current sense resistor. And what you see are this is the path that the ISL6259 has to that current sense resistor, and it's completely destroyed. So the ISL6259 is going to see 8 volts on one side and 0 on the other, and it's going to think, whoa, that's a really big difference. So that must mean the system's taking a million bazillion amps, and it's going to turn off the power rail because it's trying to protect itself. I could show you that in the schematic later. And what I'm going to do is I'm going to run this little jumper wire over here. I think we can maybe use this a little bit less exposure. Now, anything you see there that doesn't look like it's perfectly set in place, you'll see when I use the hot air that it will be perfectly set in place. I don't really care if everything isn't perfectly set in place. What I care about is that the proper amount of flux is there, so that when I use the hot air, it'll kind of move itself into place. And also, if you see any solder joints where there's a little bit of that Hershey's Kiss effect on it, that's going to be because there was not enough flux used in the soldering process, which is also fixed by me putting flux there. TLDR, you really can never use enough flux, and anybody who tells you otherwise is evil. No, that'll flow. I don't feel like turning the board around. So, but the hot tweezers are going to make all that shit flow into place. You'll see. It's going to look really nice. More flux because more better, right? We got some more work to do here. Let's just flow all this stuff into place. Yeah, you see how that all flows into place? So that's the secret, because a lot of people don't understand how with unsteady hands I can do stuff so that it looks like it's factory. And the way I get work done, even though I have very unsteady hands, is that little trick. the surface tension is going to pull everything into place to exactly where it's supposed to go. So it's not like I'm sitting there and perfectly aligning the QFN of the BGA or the resistor. I put the thing there like a total idiot who has no control over his hands, and then I flux and wait. The flux really makes me look a lot smarter than I am. I'm much more skillful. You know, I'm really defrauding all these people into thinking I have a clue what I'm doing, and I don't. It's the flux. Alright, this over here also looks really bad. I gotta see if this that corroded probe point goes to anywhere on the other side of the board or not. And this one as well. I may wind up running a wire just because I don't really trust that long term. There we go. So what I want to do is I want to scrape the corrosion without scraping the copper, which is a hard thing. Too little scraping, you won't get the corrosion. Too much scraping, you'll scrape the copper. And then once I get to the copper, cover it in solder so that it doesn't go bad over time. Excuse me. This is the point at which it would make sense to just turn the board around. Stop being so stubborn. This area doesn't look too terrible, but it does need touch-up. See all that red stuff? That's the board bleeding. I don't want the board to bleed. Hello. We'll do this. You can see this probe point is shit too. I can't trust that that's connected to whatever it's supposed to be on the other side of the board. Ah. Oh well. Roar. Just knocked everything off the board. I knocked everything off the board and the customer's watching on stream. Oh well. Oh, this is a good day. Erica, the person who sent this in is watching as I knock all this shit off of their board.
Okay. You gotta fix it, so.
Yep.
Hey, did you drop the tweezers over there? Is that
Those are garbage junk tweezers that are me. Absolute shit condition. No need to get nervous when you know what you're doing. I can fix that. Easy breezy. Cover girl. Easy breezy, beautiful cover girl. Get off the tweezer, you fuck. This shit is so small. That's the thing, like, if you've, you know, I'll feel like I'm getting it not 100% perfect, and then I just have this feeling like I have to sneeze, and without even sneezing, just feeling like I may have to sneeze, and everything just goes running off of the board, and I realize that I'm working with microscopic crap. It really puts things in perspective, that the tiniest fucked up hand movement just makes everything on the board go poof and disappear. That should be good to go.
Ooh. How's it looking?
Not bad.
Good.
Easy breezy. Easy breezy. Easy queasy. Easy queasy. So remember how I said that this probe point over here, I wasn't sure if this was going to the other side of the board properly? And if you look at it, this kind of, see this? It's like kind of half on there. That's part of the battery current sensing circuit. So to go over current sensing here before I get finished. If you take a look, you have two current sense circuits, one for the charger, one for the battery, because the computer wants to know how much current the charger is using and also wants to know how much current the battery is using. So here's where the power comes in from the charger. It goes to this transistor. What this transistor does is it essentially makes sure that if the charger is not plugged into the wall, the battery does not go back through the system and try to charge the charger. Make sure that things only go one way. So it goes through there, and then it goes to this current sense resistor. This is a resistor that is in the circuit path of the charger going to the computer. So it's in the stream. So imagine that you wanted to know how fast the stream was going in a river. You can't simply tell by looking at the water, if you're far away, how fast it's going. You'd have to put your hands in the stream and feel how much pressure it's pushing with. And then you'd have an idea of how strong the current is. And the same is true here. The ISL 6259 can't tell how much current is going through the charger just by being next to it. So what it does is if I wanted to know, if I'm on top of a mountain and I want to know how much water is going to the stream, I could ask my friend, hey, can you put your hand in the water and let me know? And give me a phone call, tell me how hard it is. Over here, the ISL 6259 has his friend R7120 put his hand in the water. And then R7120 calls U7100 on resistor R7121 and R7122. So over here, let's say you have 18 volts for a charger, right? And then you have 17 over here. It'll think, wow, that's a huge difference. That must be using a lot of amperage. Let me shut the system down. Whereas if you have 18 volts here and 17.9999999 volts here, it thinks, all right, cool, it's just being a normal MacBook, not taking too much. And since there's going to be a voltage drop from this side to this side, you have a resistor going between the ISL 6259 at the beginning of the resistor and the ISL 6259 and the ends of the resistor. Now, if this resistor is burned or this pathway is blown, then you're going to have 18 volts here. The ISL will see 18 volts here, but it'll see 0 volts there because this path is blown. And it'll think there's a 18 volt difference between here and here, which means when it does its little internal calculation, it's going to think the system is using 1 bazillion, gazillion, trizillion amps, and that's no good. And it turns it off. Same is true for the battery. You have a current sense resistor over here. So here you have to/from battery. And before it gets to the system, the first thing it gets to, current sense resistor. Before the resistor and after the resistor, each one, you have a path going to the ISL 6259, the charging chip. Now, one of the things I do, if I want to see if this path is working, I'm not going to measure from here to here, and 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 here to here, because that's a big fucking waste of my time. What I do is I add up the resistances of everything in the circuit, and then I measure between here and here. The resistance between, if this is a loop, between 27 and 28, I should just get, 10 ohms plus 0.02 ohms plus 10 ohms, and back again. Let's see if that's what I get. I'm going to turn on Paul Daniels' amazing multimeter software and see what I measure. So for Charger current sensing. Oh, I have to turn to ohms mode. For charger current sensing, 20, the path is not broken. For battery current sensing, 31.5 million ohms. The path is broken. So even if this turns on via charger, it's not going to be able to charge the battery because it's going to think it's using too much current. Now, I'm going to guess that the path is blown between here and the other side of the board. So let's see where that connects. Let's go to the schematic on the board view. Where do you connect to? Well, you go through U5600. I wonder if I can just kind of run a wire between here and there and get away with it. That would actually be much easier. Let's see. Turn on the fume extractor. And get going. If not, then I have to run a wire to the other side of the board, which would suck. And the board looks like a freaking banjo.
Don't worry, it's not like the person who has this computer is going to see it, right?
Yeah, the person who owns this is never going to see what a botch job this is anyway, so it doesn't really matter.
Yeah.
It's not like he's like watching the video in 1080p 60 in the chat.
Yeah.
Or something like that.
Probably went to the bathroom or something.
Probably went to the bathroom or something. He's never going to see this. I'm probably giving the guy a heart attack. Oh, man.
Crap. I think he came back from the bathroom if he was in the bathroom.
I like to run the wire in the same direction of the leg. It's a little OCD thing of mine. It shouldn't matter, but
Scott says let Erica fix it. Scott, bad things will happen if I go ahead and touch that board right now. Very bad things.
I believe in Erica. I believe in Erica more than Erica believes in Erica.
I believe in myself too, but I just don't believe it. I should be working on this board.
I'd let you work on it if you said if you wanted to work on this right now with the customer watching, I would say go for it. Mm-hmm.
How many caps and resistors do you want to have to move back into place or replace?
I'm sure he won't mind. Right, guy?
It's gonna look like alphabet soup.
Let's have a vote in the chat. How many people think that I should have Erica try to work on Linux Guru Gamer's board right here? What do we say?
No. There's a few rational people over here. No. Oh, crap.
Yeah, the yeses are outdoing the no's. Actually, this wire I just bent. Shit, yeah.
You bent it.
This wire is more bent. This wire is more crooked than Erica's strategy for winning plush toys.
Man, if I did a board repair video, I think I'm gonna get downloaded so hard. People are gonna angrily email you and say, Lewis,
That's
I subscribe
unprofessional.
to see you, not anyone else, just you.
They wouldn't say that if you fixed the board.
Jim says we want Oriole to work on it. Jim, I'm still trying to get Oriole to make it to the litter box.
Alright, so you got a kind of half-ass solder joint there. I can route that wire a little later. Let's see if that changes the resistance. We're looking for... So the two resistors there, I believe, is a 0 ohm and a 2.2 ohm resistor. Yeah, 0 ohm plus 2.2 ohm plus 0.01. So we're looking for 2.201 ohms. Is what I should get here if this is going the right way. Fuck you, 11 million. You piece of shit. Let's see. Wait a second. Did I just put a bad resistor on the freaking board? Oh my god.
Do you want a cookie?
No, I want a 0 ohm and 2.2 ohm 0201 resistor. Wow, the resistor I took off my freaking donor board. Oh, wow. I got trolled. The resistor on the damn donor board is no good. Piece of shit. That's the first time that's happened to me. Current sense. Okay.
First time for everything.
Well, the thing is, I save time using donor boards instead of the new resistors book, and people have always asked, well, why do you do that? Because it saves time. It's still, I mean, the amount of time I've saved over the past 7 years is still beats. Still makes up for this. Although this was a good troll. That resistor is going to be upside down just because.
What's the chances of the person owning this computer saying that you put a dud resistor?
He'll be fine. He watches the channel. He knew what he was getting into. I also got to rip his JTAG off. That resistor is upside down, just like Australia.
You didn't go on a bathroom break yet.
Okay. We want to get you to the probe point and the resistor at the same time. Is this an Australian resistor? This resistor is from the land of Paul.
Wow, look at Paul Daniels. He's telling you to hurry up. Paul, we should send you some cookies over there. Or Cinnabons.
I don't know if they have that cookies in Australia. They have eucalyptus leaves for the koala bears. That gunk over there is going to get cleaned up by the ultrasonic. Also, that was... Let's see. What do we have now? Piece of trolling shitboard. So... Oh, multimeter software. Bam! Bada bing. Close enough. Now, next up. This little piece of shit. I don't trust the way this looks. I saw a little bit of red under there. And I was right. Yep, there was a little bit of red.
What's red?
Rusting, kind of.
Oh, corrosion.
Yeah, it's not too terrible, but I don't want to leave it there. We already made this an Australian board.
What a generous amount.
Proper amount of flux there at HAKKO.
Night Jumps, what is your definition of quick? It's all subjective.
This here is superficial. Superficial, but still triggering me. Superficial, but still triggering me. Alright. Now we gotta make sure this... I'm pretty sure this doesn't go to... This is just a measurement point. It doesn't actually go anywhere else on the board. But... Oh yeah, that doesn't go anywhere else on the board. Or does it? Yeah, it does. Son's a bitch. Let's charge your phase.
What happened to this little board anyway?
Someone spooged in it.
Huh?
Someone spooged in it. Spooge. You want me to show you? That's what I thought.
Yeah. Okay. Oh.
I want to get to that nub under there.
Lewis is mining for copper.
Let's make sure that's not ground in there. Because if I dug to ground, then this is useless, and I gotta start over at the other side of the board. You're not grounds. Now, are you grounds? Ew. Nope. Wait. What the fuck is that? Yeah, not ground. Okay. Keep digging. Are you using a wire brush? I'm using a knife. Using a knife and scraping the shit out of it. Moment, I'm going to take a solder ball probably and toss it in there and use the hot air to make myself a solder pad to run my jumper wire to. Ooh, yay, I just made a solder pad. Look at that. I made a friend.
You made a friend. It's like Olaf.
Come on, get in there.
Why do you think Apple doesn't conform or coat their boards?
Why? So that idiots buy another one. Why would they do something that would save their users money? Like, why? Alright, that's good. All I wanted was a bump, and I got a bump. That's all I needed. I'm not actually going to solder to it. I'm going to tin a wire. I'm going to try to... Maybe, actually, you know what? Maybe I will try soldering instead of hot airing it in. Crest Ultrasonics was my customer for a year about 10 years ago. How hard was it to get them to call you back? I'm curious. Fucking motherfucker.
Language.
Yeah. I can't tug on the wire because that probe point is so weak I'll break it. I'll rip the probe point off the board. It's not like I can... There's nothing to really... There's nothing structurally holding that in. So I have to have the wire pushed into the board. There we go. So now I can rip this off here.
Oh.
Now I can rip it off the capacitor. The capacitor is held on by a nice beefy pad. I'm hot airing it because I want the wire to flow into place. That thing that it's soldered to, that little point, that's barely a solder pad. That barely exists. So it needs to be in the exact right spot. Now this thing over here, I don't care that this looks fucked up. It doesn't matter at all. Because that's just for testing. So see how the chip... There's a trace that comes out of the chip, and then it goes here, and then that's just a probe point for measuring. That can look fucked up, and who gives a shit? This matters because this is where it's going to another part of the machine. This is where charger phase on another part of the board is coming into the chip. And that can't be messed up, or else there's nothing going to the chip. So that fixes that area. I'm just going to rapid cool the board using our patent-pending rapid cool technology. Let's do this. Bing, bada, boom. The board loves it. The board loves rapid cool technology. What do you guys think? Fan spin? After this, I got to get a little bit of business administration work done. Eat some food. All right. I think the board's gotten itself cooled off enough. MacBook doesn't deserve to be any colder than that. Come on, little MacBook. Oh, wow, it didn't fall. Strange. All right, let's see what we get. Come on, fucker. 500 milliamps in booting. 500 milliamps in booting. Yes! Fan spin! This is a 3437, so it's going to turn on, off, on, off, on, off, on. Don't ask me why they all do that. So you do an RTC reset, not sure why. That's not a glitch, that's just it being a MacBook. So I do this, I do this. Oh, well, why is Paul Daniels' software not showing that I switched over to volts? There we go. 8.5 volts. Lewis, the state of Oklahoma violated me this weekend. It forced itself into my sinuses. Do you support right to repair for states that violate its guests? Absolutely, I do. They can violate your sinuses all you want. They could chop off your nose to spite your face. If it gets right to repair passed, I'm good. All right, so as you can see, we get 8.5 volts on PP D3 hot out the 4 volts we got before, 500 milliamps, which means the CPU's on, brain's working, and the fan is spinning, which, as you know, that's pretty much testing done here. There's not much more else to it when it comes to Rossmann repair quality control. So what was going on here is that the traces were corroded for several lines, the current sense traces that I explained to you. In addition to that, we also had another corroded probe point between, if you look on the board right over here, so charger phase goes to this capacitor. This capacitor sits between charger phase and charger boot, but charger phase is going to be this section right here. Charger phase is coming around here. Right after the transistor, so this is the way PP Bus G3 Hot's going to work. You have the charger, which is 18 volts coming out up here. This allows it to come through. Then this is going to switch on and off. So you're going to get 18, 0, 18, 0, 18, 0. And eventually it's going to average itself out to 8.58 volts. This chip is the chip that decides when this transistor, which is essentially a switch, turns on and off. So think of it like a light switch that's going really, really fast. Once it goes through the coil and as these smoothing capacitors to ground, instead of having 18, 0, 18, 0, you get a nice smooth 8.5 volts. Before the coil, but after the transistor, there's this point that goes to the ISL 6259, just so we can get an idea. It needs to remember what I've said. The chip needs to see what it's doing. If it's a DC to DC boost circuit for a backlight circuit, you have the feedback trace, and over here, you have charger phase. The chip needs to know what it is doing. It needs to know, am I switching too fast or switching too slow, so that it can adjust itself. Same thing as if you're driving. If you're driving and you're in a car, you can tell because you can see the speedometer, how fast you're going. If somebody just covers your eyes, you can't see the road or the speedometer, what do? You hit the brakes. You don't know how fast you're going. You don't know what's in front of you. So same thing is going to happen here. It needs to have this, and this was broken, in addition to the current sense traces that were broken before being broken. So we ran a bunch of wire to everything. I think that's 44 or 46 gauge Remington magnet wire. You could find links to it down below in the description, and that's about it. This board now works, and as always, I hope you learned something. I'll see you in the next video. Thank you so much for watching and for being a part of what we do here. Bye.
Does the JTAG connector help it work more?
The JTAG connector doesn't help it work more, girl.
Oh.
I'll actually have you rip that off in the next video.
What?
You excited?
No.
Rip off JTAG?
Eh.
Aw. See ya.